Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're going to come back at the end to wrap it up. Now, as you remember, we had started this tutorial on Walkie-Talkie, and we had made a promise that we're going to walk you through how we configured everything. So let's just show you the Walkie-Talkie working, and then we're going to come back and do something with the configuration. So why don't we just do that now? So let me show you the Walkie-Talkie. So let's show that working in action. What shall I render to Jehovah? For he has done so very much for me. Let's stop it there. So you can see there's a switch on that circuit. This switch right here. Let me make it full screen. The switch you're seeing here is a push to talk switch. What it means is when you push the switch to one side, it will make certain connections and then you can talk, and then you push it to the other side or you release it and it returns. In our own case, we use the latching switch, double pole, single throw. But in your case, you could use a push to talk switch, which engages only when you hold it, and then when you release it, it comes back out. So I'm going to walk you through the reasons for that. And remember, there's a video we did earlier on Walkie-Talkie, and that video is more detailed, has information on why Walkie-Talkie is what it is. So maybe I'll just recap now. Let's go and redraw that diagram, recap, show you the switch and how you configure the switch, and if there is time, we'll go back to the full circuit diagram of the Walkie-Talkie you're looking at on your screen, and then we're gonna maybe just explain how it works. So for that, let's just go and do the needful here. So now I have my OneNote open, and I'll just walk you through what a walkie-talkie is and how a walkie-talkie is designed. So walkie-talkie is a simplex transceiver circuit. And what it does is, so this is a transceiver, TRX, transmitter receiver. It has the qualities of a transmitter as well as a receiver, but it can only function in one mode at a time. It can only function as a transmitter or as a receiver at a time. It cannot function in duplex mode, hence we call it simplex. It's either at every time. For a walkie-talkie, if you go to malls, you see people using this, Canadian Tire, Walmart, and the rest of them. You see, especially Canadian Tire, you see people using this to communicate to staff, ask them about some information. So let's just, all right, I think this pen is too large, so let's make it smaller. Yeah, and now I've written it so small. Anyways, but you get the gist. So it can only be a transmitter at a time. Either it is TX or it is an RX. The combination of both gives you the TRX. So in this mode, we're trying to minimize the things we're using. So a regular transmitter, we have a front end, and let's say I'm just gonna call it RF amp, radio frequency amplifier. It's gonna have also an audio frequency amplifier. Then you're gonna have your oscillator somewhere in the middle, or the full receiver. I'm just gonna call this your transceiver. Remember, it will only be one at a time, TX or RX. So you need a switch to connect this up together. You also need your transducer. So I'm gonna put another block here. I'm gonna call it a transducer. Transducer. Um. All right. I think I need to make my box a little bit bigger so that my words can enter. This is just a fancy word for let's say speaker. Let's just say speaker. That's a way of saying speaker. So we need a speaker, and this speaker will be used for both the input and the output. But before we get there, before we get ahead of ourselves, so these are the basic blocks you need. You need the RF amp, and in some cases we don't really use the RF amp. We just use the transceiver directly. The audio amp, we could just use a transistor or an IC, and then of course a speaker. That speaker will function as the output and input, both input and output. So I'm just going to maintain it as transducer because you will see why I say that. When it functions as input, it functions as mic. When it functions as output, it functions as a speaker. So this is a sound transducer. I don't want to delete everything, so I'm just going to put sound in parentheses. This transducer is a sound transducer. So it changes its behavior with the presence of sound, or it's the change in its properties or characteristics produces sound. So when you add electrical magnetic energy to it, it will produce sound. When you add sound to it, it will produce electrical magnetic energy that goes into your amplifier or your other circuit. So this is the block diagram. Now, in our case, we used the for the TRX, we used a very simple circuit. So I'm going to draw one now. It doesn't have to be the same. You can use any other one. So, but this is one of our circuits. We have an inductor here. We had a capacitor, variable capacitor, and we had another capacitor here. I think we've tried 10 to 30 picofarads. Here, L and C, I'm not going to give you the values. So find a value that works for you. You can go to hackerworld.com and get a calculator. Pick the frequency you want and find your LC. If you have L, find your C. If you have C, find your L. The calculator has made it easier for you. All right. And then I have a resistor here. I think I should explain the values we're using, but maybe in another video, because this one is already going to be long, so not to make it too long. So here we used 2K2. I think in another circuit we used 8K2. And then here we use 150. I'm just going to put it on the other side because in the most recent video we put an inductor here, an RF choke, and we put a jumper. So we just use the jumper here. This looks like a bell now, but that's not intention. So just a jumper, you can close it, shut it. But anyways, in the final analysis we had to shut it. So let me just shut it. So this is 150 ohms. And I think this one is 20 microhenry, something like that. This transistor is any NPN transistor RF range, so I'm not going to write the value NPN, but we've used 2 and 2. You can use the same or use a different one. And here we have the output, and this output can, so this just be our antenna, right? So this can be okay, let's just call this output for now. So this is our transceiver, and then for the audio amplifier we use, you can use a transistor, but let's just, for a change, let's use an op amp LM386. So pin 6 is the positive, 4 is the ground, 5 is the out. You can connect 1 and 8 with a capacitor to boost the signal, the gain, by up to 200, but you don't need it. So then you have pins 2 and 3. Well, let's just change it up. Let's call this 3 and then 2, just because we wanted to ground this one so it's closer to 4. This is grounded. Then this is your input, so you can have a variable resistor here for volume control, if you will. And then the other end goes to ground. Okay, all right, then this one goes here. This is your input, so you're gonna have a capacitor there. Anyways, I'm trying to draw a straight line, but I'm not drawing it properly. I just need to put a dot there, and then this one. Well, I don't really have to make it go down all the way. I can, but I don't want to. I can just stop it here. Right, so this is our op amp, our audio amplifier. So this is our positive, that's ground. This is output. This output goes through a capacitor. So you can go with 220 microfarads to 470, and then this output, this is our output. Now I'm not drawing the speaker on purpose, so let's just draw the speaker separately. And then the speaker, that's our transducer. Let's call it transducer for now, even though it looks like a speaker, but you already know why we're calling it a transducer. All right, so this can be in or out, it doesn't matter. So because depending on how you're using it, when you're using it as a speaker, it becomes your in, so as a speaker. But when you're using it as a microphone, it becomes your out. In that case, for a speaker, the sound is coming out from here, but as a microphone, so this one is a speaker, but when it functions as a microphone, sound is coming the opposite direction. So we have looked at the blocks we have here. So you have the transducer, check, audio amp, check, transceiver, check. And our transceiver is very simplistic, not something complex. You can use any of our transceivers. We have had many of these, so you can use any of them. Let me use a different color. So no, let's use a different color. Just yeah. So that's our transceiver. Then that's our audio amplifier, and then that's our transducer. Now you have the basic blocks. The only thing missing here, so let's just go and check. Let's make this green and check. So we have transducer, we've done that. Audio amplifier, we've done that. Transceiver, we've done that. The only thing we don't have here is the RF amp. Now, what you could do is to use this audio amplifier as also your RF amp. In that sense, you have to change everything here. So I'm just gonna give the number for this, the current one, 386, LM386. But if you want to use that as also your RF amp, then you want to use a transistor there. So in that sense, we'll just use any of our transistors. Until we show you why we choose the values we choose. Maybe in one of the videos we're going to do that, maybe in the basic tutorials. Until we show you that, just copy the values. Copy the values for now until we show you how we find the values. So this is the amplifier we used several times. So you can use 5K6 here. We had an earlier video today where we used the same values, so we're going to repeat that. There's a video on crystal oscillator or crystal transmitter, and in that case, if you just put a crystal across this resistor, you have built a transmitter, just like that. Very simple. So again, this will be your in all cases, and this will be your out in all cases. Alright, so you can use this as your audio amplifier. You can also use that as your RF amplifier. So if you, in this case, so you can just replace this value, this audio amplifier here. Now let's go to the switch, because if you remember, we talked about a switch. Do we have that video? Oh yeah, you see that switch there. We talked about that switch, and that switch is what is doing the magic for us. Remember, we say that you need a simplistic approach. Now, for a regular radio transmitter and receiver, you need all this. You need all this for transmitter, you need all this for receiver. But when you want to build a walkie-talkie, you want to reuse the same for the transmitter and the receiver. So all you need to do is to turn it around. So first of all, this block here, I'm going to call it block A. At this point is functioning as, at each point is functioning as either a transmitter or a receiver. So when it's functioning as a transmitter, you want to set up the audio input to be going into the input of the transmitter, and then the output is going to the antenna. So let me tell you what I mean. So let's just call it block A. When it's functioning as a transmitter, as a transmitter, the output goes to an antenna. So let's say this is an antenna. The output connects there. I'm going to connect the switch here. So this will be normally open and normally closed. Normally closed is when it's functioning as a receiver, but we're talking about transmitting now. So this is the transmit path, so TX path. So when this is functioning as a transmitter, the output is connected to the antenna, so it can radiate the radio wave. When it's functioning as a receiver, the antenna is connected to this portion, and in that case, this is the in and this is the out. So that box has an in and out. There's the in here, and then there's the out here. So let's just call it input. So those two connections come out of the box this way, in and out. Of course, the power supply is going to be there always. Now that is for the box A. Now for box B, so we're going to call that the RF amp, the box B. So again, it's going to have in and out, two wires, in so the in to the RF amp, when I'm functioning as a transmitter, the in is going to come from the transceiver, from this block A. The in is going to come from block A. But when I'm functioning as a receiver, the in, when I'm functioning as a transmitter, the in is going to come from the transceiver. So my signal is boosted so it can go further. And I can also have two of this. In such that one of them is used to amplify the signal from the transducer, from the speaker, before going into the transmitter. Right, so I can have two of that box. But when it's functioning as a transmitter, the in comes from box A and the out goes to the antenna directly. So the antenna actually should be here when you want to use that stage to boost the range. But for what we are doing, don't use this configuration because we are working on the FM range. If you use this configuration, your signal might be strong enough to interfere with your neighbor's radio. Unless you have a license, don't do that. What we are doing is in the house, in a small area with low power. The transmitter has low power, so the radiation is very small. It can only go about a few feet, a few meters at most. So that's why we're doing this. Now, if you want to use the RF amplifier at the output, this is a warning. Don't do this without a license unless you're operating at the free license frequency. So find out what is free in your area according to the network regulations in your area. And then if you're operating in that region, then you can put this as the RF amp. But we're not going to use that. So let's just change this up and use it only for the preamplifier. So in that case, the in will be speaker or the out will be speaker. So the switch here, the speaker will be the switch. It goes to another box. That box is the transducer. So this is B, this is C. So in that case, C is this guy here. Now, this is also B, or let's call it B prime, because it's functioning the same as this other B. So our box C is the speaker. So the speaker, as it in the TX path, this one will be RX path. In the TX path, which means we're transmitting the audio signal coming from your voice is hitting on the diaphragm, causing vibration, creating an electrical signal. You want to send that to the input. In that case, the output here will then, so this has to be connected to two places. The output here goes to the input. So this other one too. So there should be another switch connecting this up. So these two connect together. So let's trace this end to end. When I'm transmitting and I speak, my sound, let's take a different color. Let's use this. My sound goes in here. And goes out. And when I'm receiving, the antenna switches over here. So it goes this way. Then, obviously, my speaker is now switched this way to receive. So my signal will go that way to the speaker. So that's how you minimize the parts. This is confusing a little bit. I'm going to draw it better. But just this is the theory. So when you're transmitting the same blocks, you have three basic blocks: the RF blocks, the RF block, the amplifier block, and the transducer block. So you can rearrange them. When you're transmitting, the first block is your C. When you're transmitting, because your sound starts from here. So number one, then goes into block B, which is your amplifier, and then that's number two. Then goes into your transmitter, and then that's number three. When you're receiving, however, it goes the other way around. The signal first of all hits your antenna, and then comes in from your transceiver block. So in that case, that's number one. Goes to your audio amplifier, that's your number two. Then goes to your transducer, that's your number three. The switch is what you use to arrange and rearrange the circuit. So I'm going to show you the circuit one more time, the working prototype one more time, and then we'll come back and redraw the blocks so that it can make total and complete sense to you.
What shall I render to Jehovah? For he has done so very much for me.
All right. So we've shown this one more time. Let's show you how the switch works. Or maybe we'll redraw the switch. I think that's the better word. Let's redraw the switch. So the switch has nine connections. The switch we use in this configuration, 9 pins or 9 terminals. So there's 1, 2, 3. And there is 4. Is that 9? I'll find out how many. Just give me a second. Then 1, 2, 3, 4, 5, 6, 12. 12 pins. Is that really the one we used? I'm going to confirm that for you. Right, so let's confirm the one we used and see if it's 12 pins or not. But each of these so this switch here can connect to this, or it can connect to that, and then this also. So when you push the button, let's get the actual switch that we used, and we're going to confirm. Let's confirm how many pins they have, and so we can guide you. I know the one we use is short, and hence we had to be very creative in the way we arrange the connections. But let's see how many pins really we used. And SK22D7, SK22D7, so SK22D7. Alright, I'm gonna show you the switch. We got it from AliExpress. SK22D7. I think it's not showing as one of the pictures here. It's not showing as one of the pictures here. So all right, we don't see that here. SK22D7 D07 pins. All right. All right, so it's 6 pins, not 12 pins. Let me see if I can show that on the screen. If I can show the picture on the screen. All right, so that's the switch we used, SK22D7. So it has 6 terminals. So let's show you how we use those 6 terminals to achieve what we did. All right, so let's do that. It wasn't 12. I think we desired 12, but we got 6, and we figured out a way to use the 6. So 3 on each side. So which is actually half of what we've drawn on the screen. So let's just delete that and show you what we actually did. All right. So 1, 2, 3, 4, 5, 6. So there are 2 switches here, or 4 switches if you will. There's one that goes between, this one here goes between this and that. So let's just number them 1. Let's use black. 1, 2, 3, 4, 5, and 6. So when you toggle this switch, so you have 1 and 2, 1 and 2, and 4 and 5 at the same time connected. So 1 and 2 connected, 4 and 5 connected. When you push it the other way, it becomes 2 and 3 connected and 5 and 6 connected. So double pole, single pole, I think is a double pole, single throw. Double pole, single throw. So you have 2 poles, one here and one there, but you throw it, you just push it one time, right? So there's double pole, double throw, but I think this one we use here is a double pole, single throw. So one switch in action, you get to where you're going. So that's how. Oh, I think this is actually double throw. Sorry, I think I misspoke. This is double pole, double throw. Double pole, double throw. All right. So the switch is double pole, double throw. So so I'm gonna change that nomenclature because I don't want to mislead you. So it's double pole, double throw. All right. So, but you can use another switch if you will. Right. So now to connect this, we have to figure out which boxes. We have 3 boxes, A, B, and C. So first of all, you can connect your speaker here. The transducer, you can connect your transducer here. So that's box C. And then you know your speaker, it's either going to the, so let's go back in here. So the speaker is either going into the into block B, or it is going to block A. Actually, into different parts of block B. So block B has input and output. In, out. This is block B. This is our amplifier. So the speaker, it's either acting as input or it's acting as output to the same amplifier. So you have to find a way to connect this up, and they have one wire from the speaker. So this is your C, block C. But then when you connect it this way, the other side, so let's say you connect it this way, the other side of the amplifier should go into block A. That means you have to link up one of these. You have to link up this or that. You have to find a way to link it up. So let's just draw it in full. Let's draw it in full and then we come and analyze it. So I can't make this fast because I'm really doing it live. So I can't make it fast. So you're just gonna bear with me to draw it out in full. So A, B. I'm going to try to be as fast as I can. C, and you know that C is the speaker, right? So I'm going to take different colors because they're going to be crossing. This color goes in here, and so the two sides, the options I have here, it's either it's going into the amplifier. So the amplifier is 2 wires. So I'm gonna take these two options, right? And then for my block A, I don't have to highlight it, I can just mention it. For my block A has input and output. So I need a connection to block A. When I'm transmitting, I need the input, so this is in for A and out for A. So I need my in to be taking a signal from block B because this is the audio amplifier input, and then goes to the antenna. So my out, I'm just gonna have my antenna here. Let's just fix the antenna permanently for now. Then the input, then let's take a different color. The input um the input should go here. Is that right? So if I have my input here, then it can take input from this point or that point. So it can take input from either 1 or 3, going into the amplifier, going into the block A. So let's see if that makes sense. So then what I need to go in there is my audio signal from block B. Remember, I've already drawn this, but I want to walk you through how I did it. So for block B, the output, which is here out, the output of B goes into A. So I'm gonna say when I'm transmitting and the speaker is in, which means I've closed this path, then this is also closed. If this path is closed, that path is also closed. That means what I need to go into the input must be connected to this pin. So the speaker, first of all, goes into the amplifier. The amplifier gives me a signal out here. That signal out here must go into the input. So I have to find a way to short. Let me use, I've used red. What color haven't I used? I can't use white. Let's use blue. That means I have to short this to this, so that when the pin 1 and 2 are connected, the signal, the output from B, the output signal from the amplifier is connected here and then goes into my input and then goes to the antenna. On my receive path, I need the output. So on my receive path, so I need to connect this on the receive path. So let's deal with our receive path now. On my receive path, this will be closed and that will be closed. So if this is closed, then signal coming from the output of the let's use a different color. Let's use red. What other color do we have? Okay, let's use this one here. So this connects over here. So let's trace the path. So the output goes there. So when I'm receiving, the signal coming out from the transceiver, in this case a receiver, goes to pin number 3. But that time my switch has closed this way. So it goes to pin number 3. But then that means that pin 5 and 6 are connected. So The 5 and 6 being connected means that my speaker is now connected to the output of the audio amplifier. The audio amplifier goes to my speaker and then can give me a signal out. But I think there's a mistake here, because if I short this to here, speaker amplifier out, block B out goes to my speaker, that's right. But block B in, there's nothing on block B in. So how do I get my block B in? Because my block B in must be connected to the block A out. My block B in must be connected to block A out. So that means my block B probably should have been connected in the middle here. So let's see that. Let's connect that in the middle. All right. So if we have it that way, then it can take input and it couldn't have been this way. It's gonna be infinite loop if we do it that way. So we're gonna clean this up and we have to redraw it. All right, and then we're gonna show you the one we already did. Maybe we should just show you the one we already did, or we just draw it afresh. Again, let's show you what we did already. I'm going to try to log in and show you what we did already. I'll just continue to let's see. Right, easy. It's kind of user center workspace, and we're gonna do that. Go to opening editor, and okay. Alright, so let's show you, because I think it's much easier when we show you what we've already done. So let's zoom into that spot. Let me see. I was gonna say let me know if you can see what I'm showing, but you can't. Let me know. Let's do it here. Yeah. Alright. So that's what we did. We have the speaker going into let's just take the live wire. The speaker is right there. Let's make it bigger and hide all this. Yeah. And then you have the toggle in the middle. So this is the switch. We have two of them, like we said, it's double pole, double throw. So we have two of them. So it's either connecting to this point to that point. So 1, 2, 3, 4, 5, 6. There are six connections. So the speaker is connecting to looping 2. So that's the speaker. And then the middle is either the input to the amplifier or the input or the output from the amplifier. So the amplifier is either sending signal to the speaker or is sending signal to the audio input. So let's redraw it because I think it's easier. So I'm gonna bring up the So the output is sending signal to two places. One of them is it's either going to the audio amplifier, sorry, the audio amplifier block B is either going to the speaker or it is going to the input. Speaker or to the input. So we have to put it that way, the audio amplifier. So block B is either going to the speaker or it is going to the input. So let's take this wire here, and we're saying one wire from the input of the transceiver. The input of the transceiver is just one spot. The input of the transceiver is one spot. So let's just put it here, one spot here. All right, and then the center of that switch goes to the output of the amplifier. The center of that switch, which is this one, goes to the output of the amplifier, which is here. And then the other end of it, the other end of that switch goes to the transducer, which is C, goes to C. So the other end, which is this, goes to C. The right. So that's one side connected. Then the other side, the center of that side, goes to the input of the amplifier again. So I'm going to use a different color. Let's use red or green. Let's use green. So the other side, which is here, goes like this. That's the second switch, because we have two switches, double pole, double throw. So the center of that goes there. Then the one end of it goes to the speaker again, and the other end goes to the where do we connect that? It should go to let's just analyze this. The other end should go to the input, the signal or the output of the audio amplifier. Yes, because that's the only piece that is missing right now. Yeah. So the output. So the output of the audio amplifier. Let's use a different color. So this output will go here. Yeah, and the other one goes to the speaker. That means the speaker will have will be tied twice. So this end, this one goes here, and this end goes to the speaker as well. Now let's analyze this. It's kind of confusing, but let's analyze this. So when I close the switch, I'm gonna name it 4. I'm gonna give it 4 numbers. So 1, 2, 3, and 4. But we already used 1, 2, 3, 4 before, so let's just give it alphabet A. We've used alphabet before, so what I'm gonna use? Let's use X, Y, Z. W, X, Y, Z. Let's do that. So when X and Y, when W and Y are closed, W and Y are closed. So let me assume I'm going to transmit. W and Y are closed. That means my signal, so on the transmit path, let's say, my signal goes in from this point from the speaker. Let's use highlighter from the speaker It is at point number 3, but there's nothing connected there. So from the speaker, it goes into point number 4. And then because the Y is closed, that signal goes in through here to the input of the audio amplifier, and then comes out from the output of the audio amplifier and goes in here. But this one, W is also closed, so it goes through W and then goes to the input of the block A, which is the transceiver, in this case functioning as a transmitter. Then it goes out. All right, so all these colors are confusing, but that's the path. Then when it is in the receive path, on the receive path, let me use a different color. Signal comes in from here and then goes in here, but in that case X and Z are closed, so it goes in here. X and Z are closed, so it goes to the center here, comes into the input of the audio amplifier through the output of the audio amplifier and goes to pin number 2. But pin number 2 is closed, X is closed, so it goes here and then comes back out into the speaker. So the loop is complete. It's kind of confusing, but it's complete. So I'm gonna draw it one more time. I've shown you the circuit diagram because we've already built it, but I'm just trying to talk it through to make it easy. But I don't think I'm doing I'm making it easy right away. I think I'm just trying to, okay, I'm trying to get a black pen. Why am I using yellow? I need black pen. Alright, I can't get black pen. Let's try another color. Okay, I'm stuck in yellow. Alright, so the computer has gotten us stuck in yellow. Alright, and I don't want to use a Mac, I just want to use, okay, something is wrong with the software, so I'm gonna put the pen back. I don't know why it doesn't want to work. Alright, finally. Alright, finally it's working. So let's draw it one more time. So we have 3 blocks we're dealing with. We have A, B, and C. Supposed to draw a block, not write C. This is the transceiver. This is the amplifier. And this is the transducer. Alright. So, and all we want to do is rearrange this in any particular order. So when we want to transmit, so this is block A, B, and C. When we want to transmit, we want to arrange it this way: C to B to A. And when we want to receive, we want to arrange it this way: A to B to C. That is the function of the switch. Rearranging this in this order: C to B to A, or A to B to C. That's what you want to do. So if I then add a switch, I want to take my audio from the input. So I'm going to draw the switch again. And because I have limited number, I have just 3 pins, 1, 2, 3, for one pole, and then another 3 for the other pole. I have 2 poles, 2 throws, double pole. I want that when I switch this, when I push the switch, this will close at the same time as this. When I push it the other way around, let's see if I can get a different color without this getting stuck again. This will close at the same time as this. That's all we want to do. But we figured out that to do this, the speaker has to we have to really be very creative with our speaker. So the speaker, which is the block C, has to be able to supply inputs at different times, either input or output. So if you see what we've done earlier, we had both switches on the B, because B is the common, is the common block here, and always at the same spot. So we must connect this to B. We must connect this to B. B being the amplifier. So B is taking input from the speaker and giving outputs to the transmitter, or is taking input from the transmitter and giving output to the speaker. So B is in the middle all the time. So B can toggle between two of them. So the audio amplifier B can take input from C, or it can give output to C. So when I toggle the switch to we call this W, X, Y, and Z. When B is closing W, when B is closing to W, the signal is going from let's call this 1 and 2 and 3, 4 and 5 and 6. The signal is switching between 1 and 2. And when B is closing X, the signal is switching between 2 and 3. Likewise, when B is closing Y, signal is switching between 4 and 5. When it is closing Z, signal is switching between 5 and 6. So that's the way this arrangement is. So in that case then, we have to find a way, a very creative way, to make sure that our speaker is functioning as a transducer, and of course as a transducer, but as a speaker and as a microphone. So the input, depending on where we put our input, so if we put the input here, let's just call this B in and then B out, because B has input and output. So let's just call this TX path and this RX path, because we have to. One must be TX and one must be RX. That's the two options we have. So when B is functioning as a transmitter, when the system is functioning as a transmitter, in that case, B is feeding A. So A will be here. A in will be here. Then B out, remember this is functioning as a transmitter. Then B out is when this is functioning as a transmitter, when it's functioning as a transmitter, let's just do this again. B in is the input to B, which should go to C out. C. So I'm just going to remove this wire here and we do the analysis until we get there. Let's just connect to this one until we get there. When B is functioning in the transmit path, the B in we go to speaker in, C out. I think it's the same pin because it's just one pin. Therefore, the signal coming in from the speaker goes in through here, goes in through B in, comes through B out to this point. But B out at the same time is closing Y. B out should go to A in. So that's how you do your analysis. Again, you can just copy what I did. I'm just trying to explain this because when you do for multiple pins, you have to analyze it yourself. So B out goes to A in, and then A out will go to the antenna straight because we don't have so much pins here on our switch. So A out just goes to speaker to antenna directly. A out antenna connection directly. That's how we did it here. So that's as a TX path. But on the RX path, B in is closing X. So 2 and 3 are closed. Also 5 and 6 are closed. So B out is closing Z. So let's say on a receive path, B in should take its input from A out. So signal comes from A out into B in. Coming from B out, this must go to speaker. So this is C. Let's go to C. It should just be C because really C has no in or out. It's just C. But we already have C on that end. That means we have to shut this to that so that we just have one connection. So we don't have to have this one again. We should just have one connection to C. So on the receive path, you just have the speaker, the transducer is connected here. When you close it on the receive path, the signal coming from the amplifier is playing to the speaker. When it is a transmit, this portion is open, this Z is open, but 1 and 6 are connected. And because 1 and 6 are connected, that C is present in 1 and present in 6. And W is closed. So that C goes into B in, provides input to B. B amplifies the signal, returns it to B out, and then that B out is connected to A in, and then goes through A out to the antenna. And that's why you see in our circuit diagram, let's just go back there. In our circuit diagram, we're not really the circuit diagram, in one of the block diagrams, I think it's a block diagram, yeah. Here, no, not that place, this is what I'm looking for. Here, we've connected the antenna directly to the output. It's always connected to the output. So now I think this has cleared it. If anything, you can leave me a question and I'll try to respond. But really, in this switch here, I have 3 and 4 connected together through this loop, going to the speaker. And then in this second connection, I have 1 and 6 connected together. So depends on what you choose. The only reason I'm showing this, I could just show you what I did and then you can copy that. But the only reason I'm showing this is that you don't have to really depend on someone. That's the whole purpose of my videos. The whole purpose of my videos is that you don't have to be asking people, what part did you use? How did you connect that? You get the idea and you run with it. I spent time, I've made the video already. And I could just show you and draw the circuit diagram and get away. But the modus operandi, the motto, the reason I'm doing what I'm doing is to actually show you and teach you and encourage you and tell you that you can do it. Right? You don't need to just wait and have someone do the analysis and finish. It's good. You can just copy it. Like I said, you can copy it. This switch is let me just write the number. I think it's SK 22 D07. That's what we used. If you want a circuit diagram, we can also share with you. SK22D07. We got this from AliExpress. You can get it from eBay. You can get it from different places. You can get it from Amazon. You can get it from DigiKey and the rest of them. You can get it from so many places. Linear.com. Any place they sell electronics, they can. I think they do sell this. But we got ours from AliExpress. Now you can use the same, or if you have another one, you don't have to order what we ordered. That's the whole purpose of this, is that you don't have to wait and order the same parts and wait for it, because sometimes the zeal to do these things is fleeting, and you just want to know that it works, and then you can go ahead and start being creative and making other things. So if you have any switch, you know that your transducer, this is box C, your transducer has two connections. One pin from the transducer, one of them goes to ground, of course, but the only pin left has two connections on that switch. So you put it there, and it's not even the switching part, it's one of the poles, one of the pins. So you connect it to either 1 and 6 or 3 and 4. That's where you have to connect it. Then the amplifier, which is a middleman, if you remember what we talked about here, as on the transmit path, it is CBA. On the receive path, it is ABC. So whatever you do, you must go through B. That's why B is in the middle of the switch. Now I could just say this at the beginning, but you followed me, you made the mistakes, we went back and fixed it and stuff. I already have it done. I could just show that. So when you make mistakes, it's not the end of the world. You just do the analysis again and see where you made the mistake. Or you just jump to the end and copy what I've done. Or you follow me and see how I eliminated certain things. And I did it twice, and I did it differently. You can see this one here was different. I have one, I had, so this is pin 1, and that's pin 4. I had 4 and 3 connected together to go to C, but in the second one, I had 1 and 6 connected together, 1 and 6 connected together to go to C. You can, you see, you're not stuck. You mustn't do it exactly the same way. Just know the way the switch works. 1 and 2 will close at the same time as 4 and 5. You should know that. So, and if you choose that is your transmit path, so be it. If you choose that way, then just do your analysis. Whatever you connect here into, if it is B in or B out, depending on what it is. If you make it B out, the flow will be different. So if you make it B out, then 5 will be B in. Then you're checking. So your speaker must be at 4, because if you're closing this path as transmit path, if you're closing Y as your transmit path, then and your B in, let's just remove this. This is just to recap, and then we can. So if this becomes my B out, which makes this one my B in, then my speaker must connect to 4. That's what we did previously. But in this case, we're doing it the other way around. We're making this B in and making that B out. So if you swap it, just know the flow. Just do the flow. So the amplifier input of the amplifier must come from the transducer. That's just it. If you're transmitting, the input must come from the transducer. When you're receiving, the input must come from the receiver, from the receiver circuit. That's it. Then the output must go to the transmitter if you are transmitting. If you're receiving, the output must go to the speaker. So just that's what you have in mind. That's all you have to tell yourself. When I'm transmitting, the output of my amplifier must go to my transmitter. When I'm receiving, the output of my amplifier must go to the speaker. And then this other one is just opposite of this one. Right? You can see if I cross it, this go here and that goes there. That's just it. So we've done. I think we've covered this so well. Next time we're gonna be switching to other tutorials. We're gonna showing you other awesome things that we've done. Please subscribe, share this video, let others know about it. Again, this is supposed to be on the other channel, so I'm gonna try to move it over to the other channel. This is in that channel that I talk long and demonstrate and draw pictures and show these kind of things. So I'm supposed to put it on their channel, but I started streaming on this channel instead. So without even realizing that, so I'm gonna make a copy and put it on the Hacker World channel. HackerNet channel is supposed to be brief, but I started the streaming already, and it's an hour later, so I don't want to do it again, so I'm just gonna make a copy and put it in Hacker World. So go and watch it there. Watch other videos in Hacker World, and also subscribe to that channel as well. This one here in HackerNet. Please do share the video, subscribe, ask your questions. We try to answer as much as we can, and if we can't, we'll research and get back to you. All right. So I think this will bring this series to an end, because it's really long. So next week we're gonna look at other awesome projects. All right. All right. Thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now. And don't forget to like and share this video. Until we come your way again with more contents, stay enthused.